Okay, so we are good to start for today. Now, today we'll be starting with Docker and then we'll follow up with Kubernetes. So let's start with Docker. Now, the first question which should come to your mind is, why do I need Docker? Okay, what is the reason behind that? And if we talk about Docker, what is a Docker image? What is a Docker container? And after that, we will be talking about the components of Docker and how do in real DevOps world, I will be using Docker. So first, let's understand why do I need Docker, or what is the problem which industry used to face, which I'm trying to address. Okay, so the first thing is, one second. Okay, so the first problem here is that now let me say I am a developer. Okay, now as a developer, I am going to write the code. Now to write a code, let me say I'm writing a Java code. Okay, so to write a Java code, I will first install certain softwares like Java itself. I will use a third-party tool like Maven. I will be using a code editor like Visual Studio Code or Eclipse or something like that. Okay. Now, after doing all these things, I will start my work, or I will start writing the code. Now, after the code is done, I will go ahead and test my code, whether it is working fine or not. So once the testing is done, I'm confident that the code is fine and I can take that code to UAT environment or test environment or production environment. Now, the moment you take the code to production environment, the team who is sitting there, the production support team, is saying that your code is not working. And because of your code, my CI/CD pipeline is failing, or my production environment is not working as expected. So you will say, what? I just not tested the code. It is working perfectly fine in my environment. Why is it not working this thing? So Anji and Gopi, we will come back to this SonarQube thing. Just give me some time for that. I will tell you how to implement that probably tomorrow, day after tomorrow. Okay. So now the developer says that, come on, what happened? It is working in my laptop. I just now tested it and I have given it to you. How come it is not working on your this thing? So you will again take back the code, try to test the code, and then again push the code to prod environment or UAT environment. Okay. And again, it fails. Now you are super confused that if the code is working fine in my laptop, why the hell it is not working here in the production environment? And the prod environment guy simply says that it is not working. And you don't know the exact reason why it is failing. Okay. Now, what can be the problem? So I will say the problem is because the two environments which we are talking about. So one is the dev environment and the other one is a prod environment. So the two environments which we are talking about may be different. How come it is different? Now assume that you are writing your code on Java 11 and this prod support team is trying to run this code on Java, let me say 8. So they are running on Java 8 and you are using Java 11, right? So first, the software which you are running the code is different. Okay. Second, one second. So first is the software at which you are running the code and the software which the prod environment is running may be different. Here, maybe you are using Windows machine. Here, they are using Linux machine. So I can see that net, there are high chances that the two environments are different. So what is the problem here? So this is the problem. So let me say there is two developer. One is using a Mac operating system. The other one is using a Linux operating system. He is using different set of softwares. He is using different version. So the installation of each software, okay, on different operating system may be different. One went with recommended settings. The other went with custom settings. The operating system can be different. So in short, what I see is that there is a dependency in the environment. And because of that, I will not be able to run the same code which is running in my dev environment onto my production environment. So this is a problem. And this is a day-to-day problem, or this problem was there in our IT world every now and then. Now, as a development guy, you are not aware what is happening in the production environment. And as a production support engineer, you are not aware what is happening on the other side. Okay. So this is known as wall of confusion. You think you are right. You think you are right. You both are fighting. At the end, what happens? The customer is the one who is suffering because the customer said that time to market is important. I need the software fast. And in that course, you are not able to meet his expectations and he is suffering a loss. Now, what is the solution to this? If there is a problem, there has to be a solution. So the solution is Docker, or to be very precise, the solution is Docker container. Now, when I say Docker container, or I simply say Docker, what do I mean? So I mean build, ship, run any software anywhere. Now, what does this entire statement means? So there is a tool which has one-liner definition. What does it mean? So it says build. Now, what is build for me? So let me say I am a developer. Okay. So when I write a code, the code is written in some high-level language. It can be Java, Python, .NET, anything like this, but it's a high-level language. More importantly, it is a human readable language. Now, the machine will definitely not be able to understand this code. Whatever you're writing, the machine will not be able to understand. So to make the machine understand, we convert it into binary format. Okay. So to do that, we say, I am going to compile my code. When I compile my code, there are two things which I get. One, if there are any syntax issues, that will be sorted out. And if there are any other issues like version compatibility is not there or any other problem is there, then it will be highlighted. And I will not get this binary format. But once I get this binary format, I can deploy this piece of code to my prod environment. So I can deploy this. So when I say deploy, I'm moving it to my production environment. So let me say this is my prod environment, prod. Okay. Now it looks very easy, right? That I will write the code, I will compile the code, and once the code is converted into a binary format, I will deploy the code to production environment. But trust me, it is not that simple, not that easy. Okay. So I need a tool which will help me to take care of this. I just now told that the Java version may vary. There is a developer who is using Java 8. The other guy is using Java 11. The other guy is using Java 17. There is one guy who is using Python 2.7. The other is using Python 3.6. And the next guy is using Python 3.8. So there are high chances that something which is working on machine 1 is not working on machine 2. So I need a tool which will make things uniform so that it works throughout. If it is working in my laptop, it should work on the server also. If it is working on the server, it should work on the Windows machine also. So it should work throughout. So the first thing which I came to know is that when I compile the code, I get the binary format and also the syntax check is done. It means compiling the code is important. Now in CI/CD world, we don't say that we are compiling the code. We say we are building the code, B-U-I-L-D. So we say we build the code. Now, why do we say we build the code? Because when we are working, there can be multiple programs. There are 10 developers who are writing the code and trying to push their changes. So I will say we are building the code or we are compiling the code. So the first phase is you can build the code and convert it into a binary format. The second phase is you deploy. So when I say deployment, it is moving your artifact. So this binary thing, I will say artifact. So you are moving this artifact from your source system or from your development region to production environment. So let's go back to our definition. What does it say? One second. So you can see here, it says You can build, ship, run. At the end, when I'm writing a code, I want to execute it. So you can run that code, any software, on any software, anytime, anywhere. So this is going to happen via Docker. Now, the question will be asked is, how come is it possible? Like, you are talking any software, anywhere, anytime. How is it possible? Now, this is possible because Docker uses a methodology called as containerization. Okay. Now, this word may look new to you, but don't worry, we will go ahead and explain this. So the first thing which we want to explain here is that, so there are two terminologies which we will be talking about. One is containerization, and the other one is virtualization. Okay. So these are the two terms which we will be learning right now. What is containerization and what is virtualization? First, let's talk about virtualization. Now, let me start with a very simple example. Okay. Now, let me say I am staying in a 3 BHK apartment. This is the first room, second room, and the third room. Now, I am staying all alone. Okay. I am not sharing my resources or the room with anyone. So let me say I end up paying $30K per month, which is a huge amount. Now, I want that this cost should go down. More importantly, the resources are getting underutilized, right? Why they are getting underutilized? Because at any point of time, you'll stay in any one of the room, right? The other two rooms are always locked. It means these two rooms are getting wasted. I am underutilizing my resources. I am wasting the resources, and also I'm paying a higher amount for all these things. Now, what can be the solution? The solution can be that you start sharing this with other friends of yours. So let me say I call a friend of mine, he's staying here, and the other guy is staying here. So as of now, I have two more friends who are willing to share this 3 BHK apartment with me. Now, what is the benefit of this? Now I end up paying only $10K per month. So the cost goes down. So it is cheap. And the resources are getting fully utilized. So these are the benefits when I talk about my sharing the resource. But now you can say, fine, if I am sharing my resource, is there a question on my data privacy? Is this component or is this person completely isolated? Similarly, this guy, similarly, this guy. Now, the world of virtualization works on that principle only. It means that if there are three individuals, let me say again my 3 BHK apartment, if there are three individuals and each are sharing their room, so they should maintain complete isolation. Complete isolation in the sense that the person staying here should not go and trouble the person who is staying here. Okay. Similarly, the person staying here should not go and trouble this guy. So if this thing happens, it means that I am virtually private. If you see at a very high level, you are sharing the infrastructure, you are sharing the room, but yet you get private access. Your bedroom is separate, your toilet, kitchen, your toilet is separate, but you are sharing few resources like the kitchen, the pathway, the balcony. Now these things are being shared, but still you are not putting any trouble for anyone. Now, what does it mean for me? And how does it work in my real-time environment? In real-time world, when you talk about cloud in general, okay? So cloud gives you shared login, or when you say there is a big infrastructure which the cloud has. Let me say this is AWS, okay? This is AWS cloud. So what does AWS does? It has huge capacity. So there is one person who says, I want 1 GB RAM and 20 GB of storage. It says, okay, take it. Then another person comes, he says, I need 4 GB RAM and let me say 50 GB hard disk. Similarly, another person comes, he says, I also want 8 GB RAM and 2 TB hard disk. Now, the very important thing which we see here is, yes, we are sharing the infrastructure. So this infrastructure is shared. You can see it is shared, but a complete isolation is maintained. When I am working on my cloud machine, I am sharing the infrastructure with some other guy. Okay. But I'm not aware who is that some other guy. And I get 100% privacy. I get complete isolation. Now, this methodology or this way of working is known as virtualization. Google is a very good example of that. When you type something on Google, like best salon near me, it will give you a output. Immediately, it will give you an output. It will give you an output in such a way that you get a single user feeling. You will feel, okay, I am the only one who's sitting and requesting Google for details, but that's not the case. At that point of time, along with you, there can be some another 10,000 users who are parallelly accessing the server. But Google always gives you a single user feeling. And that is exactly what we are trying to achieve here. We are trying to make our infrastructure to be shared, but the sharing is to be done in such a manner that nothing is without isolation, or the complete work which I'm doing is fully isolated. Now, this is the first concept of virtualization. Now, let's move to the other concept, and then I'll relate both of them. The second concept here is containerization. Now, in general terminology, if I say containers, okay, then you should be thinking about this guy. Shipping containers. So if you see a shipping container, it will look something like this. Okay. And a ship, which is carrying a good amount of items. If I go for something like that, images. A big shipping container or a big ship which is carrying a lot of containers will look something like this. Now, if you see each component, okay, each container is a isolated environment. So if I talk about this guy, each component is one isolated environment. This component doesn't know what is happening here. This component does not know what is happening here, what is happening here, what is happening here. They are sharing the infrastructure. The same ship is carrying everything. Let me say the source is US and the destination is India. So all the containers are coming from the same ship from US to India. But the container next to this, so let me say this container does not know what is here. This container does not know what is here. So this concept is used in Docker containers. Okay. So first thing is virtualization. I told you what is virtualization. Now the question comes, what are inside these containers? Or when you say Docker containers, what is inside a Docker container and why do we need to maintain a isolated environment? Now let's come here. Okay. So let me say that again, let me come with an example. Now let me say that you have been given, you did not get your lunch today. Okay. Suppose. Then you go to a shop. Let me say you go to McD and you say that I need a burger. Okay. So that guy gives you a burger. He packs everything and you gives it to you. So you say burger. He gives you burger, but only burger. Apart from that, he does not give you anything. When you come home, you say, where is sauce packet? Where is tissue? Water bottle? Okay, or something else. So where are these ketchup packets, water bottle, tissue paper? He did not give me anything like this. So you get a very bad experience. You have a bad experience. Now, again, you go to a different shop and you order a burger. And with the help of that, or with that order, you get other items also. So you get burger, but on top of that, you get the tissue, you get up your ketchup, you get this water bottle. So you get everything. So now if you open, it is self-sufficient. It is good enough to give you a good experience. Okay. So if you see, this is a independent environment, means you can stay at your home, your park, or anywhere, just open the packet, have food, wash your hand and come out, right? Here, you have a bad experience because the necessary items were missing. Now, the exact thing, if I have to replicate in my IT world, what should I do? Now, as a developer, I will write the code. So I have written the code. Once the code is written, I will compile the code. And I just not told, the moment I compile the code, I get artifact or the binary version. Earlier, what we were doing is we were shipping this binary version to the higher environment, or let me say UAT or prod environment. And there we see software issues or environmental issues, I will say. Versions are not compatible. Some software is not running, something is running. So it gives me a bad experience. Or many a times, the code itself does not run. I have hundreds of complaints. The tester says, what have you given? It is not running. The production support guys scream and say, no, it is not working. Right. So what I can do is I can change the way I work. As a developer, I will give them everything. I'll give the code. I will give the software which I have used to compile the code. I will give them the binary file. I will give them the libraries I have used. So basically, whatever is required to run the code, I put everything in one package. So whatever is needed, I put everything in a package. And I give it a name as container and I ship it. Or I deploy it. Now, the moment anybody who opens this package, he will get everything. He will get the code, the software, the binary files, the libraries. So he will get everything. So he doesn't have to install anything. He doesn't have to take care of the versions. He can simply take this package and run it. In our Docker world, we say this package is a container. Now this solves my problem. So now coming back to my problem, which I was just now discussing before starting the class. I told that the problem with me is that the developer is only developing the code, running in his local environment and giving me the code, or to be very precise, the binary version of the code. But when I run the code in production environment, does not run, fails due to version incompatibility. So there is a wall of confusion and creates problem. So what I do is I start using Docker containers. In Docker container, the first thing which I see is build, means you can compile any code, you can ship it and run it in any environment, any software, anywhere. So now the code which I'm going to write is no more environment dependent. It can run under any circumstances on any environment. So it says Docker is a tool which is designated to create, deploy, and run applications with the ease of using containers. So now I will be using containers. And when I talk about containers, I'm not talking about the containers which is here. I'm not talking about these physical containers. I'm talking about my Docker container. And this Docker container will allow the developers to package an application with all the requirements like your libraries, dependencies, and ship all of them as one package. So now I'm not only sharing my code, but also sharing everything along with that code. Everything means the binaries, the dependencies, the software, the code, everything. That ensures that the application works seamlessly in any environment, let it be development environment, test environment, or it's a production environment. So I started with a problem and now I have a solution to that. So a container for me is a portable artifact, means something which I can put everything together and I can ship it from one environment to another. So it should be shareable and can move around. Now, whether it is a development environment, production environment, that does not matter to me. I will simply go ahead and move things here and there. So a container is a way to package an application with all the necessary dependencies and configuration. Earlier, what was the problem? Earlier, the problem was that the developers, the testers, each one of them had different environments, and there are many installation processes, and there are high chances that you are using one way of installing, the other guy is using another way of installing. The version of softwares which we are using is different. So that makes my environment different, and hence the code does not run as per the expectation. So I was to solve the problem, and I luckily, or I have happily solved my problem. Now, before we start talking about Docker, let's talk about the components of Docker, or let's talk about the architecture of Docker. So when we say that we are going to talk about the architecture of Docker, Docker basically consists of three components. The first component is Docker CLI or Docker client, which you can see here. Then you have Docker host, and then you have Docker registry. Now, one by one, we will talk about each one of them. Now, the first thing which I should, before going here, I should talk about is how to install Docker and where to install Docker, or which version of Docker should I use. So to talk about that, let's go to the official website of Docker, which is docker.io. Okay, so there is an official website called docker.io. You can directly go here, or you can say Docker install. Okay, so it says install Docker engine, the first docs.docker.com. It says install Docker. Now it says, what is your operating system? Are you using a Linux machine, or using a Mac machine, or using a Windows machine? It is compatible with all the three versions of that. So 64-bit is present in all the three of that. Second is, if you are using Linux machine, what is your machine? Is it a CentOS, Debian, Fedora, Raspberry Pi, RHEL, SLES, Ubuntu, or binaries, means some other format? Some other formats are also there, then it is supported. So one thing which I see here is that this particular software is compatible with almost all the operating systems. Okay, whether you are using a virtual machine, you're using a cloud machine, or you're using a Windows machine, whatever it is compatible with everything. Now, let me say that I am going to use a Ubuntu machine. Just click on this and it tells you what is the prerequisite. Okay, so it says you should have the Ubuntu 18.04 version or 20.04. So these are the versions which are supported. And if you are using some old version, these are the set of commands which you have to run. Okay, now we will be installing Docker and all later. When we need, we will be installing it. But as of now, I will go with the environment which is already available. And here I can go ahead and simply run my commands. Okay, so I will come to this later. I'm leaving few things right now because I want to finish some other topic, and then I will slowly come back to all these topics. So basically what happens is that when you start learning, you will feel that it is like a ball of spaghetti or chowing in our term. So if we just lift one thread, the other two threads automatically come out. But that does not mean that I will not finish it. I will finish it everything, but one by one. So I just came to know that there are a set of commands to install Docker. But as of now, I'm not installing Docker. Rather, I'm going to work with an interactive shell. Now, Again, if you come here and say interactive Kubernetes shell. So I'm going to Kubernetes shell. Okay. So if you come here and simply say interactive Kubernetes shell, you will see a lot of links are there, but you will see official website of Kubernetes, which says kubernetes.io, Kubernetes basic, create cluster. So like this you will find. So you will come here and simply say interactive tutorial, and you can go ahead and click on this link. Now, the good thing here is that you get a ready-made console, a CLI, where you can start practicing your commands. So anyhow, as I told you, we will be installing on a cloud environment and all those things. But as of now, I'm simply trying to see how does a Docker environment look like? What are the commands which I should be running and all those things. So I'm going for a ready-made solution. I will simply come here and say interactive Kubernetes shell, and here it says click to launch. So you can wait for a minute and you can click on this, and then a new terminal or a new command line interface will be popping up. So I'll wait for this to pop up so I can see here. Now this says full screen, so you can go and click on this, and a black and white screen, or you can say black and green screen is popping up here. So it says Kubernetes Bootcamp Terminal. So you should know, or if you don't know, no worries, that to run Kubernetes, I need Docker. So if I come here and say Docker -- version, I will see Docker version 19.03 is pre-installed. Okay. So I'm not going into Kubernetes now. There are a lot of things which will come. I'm simply trying to concentrate on Docker. And when I'm concentrating on Docker, I just use my Kubernetes terminal. That's it. I'm not doing anything related to Kubernetes right now. Came here and saw whether Docker is present or not. So I simply said Docker -- version, and I see Docker 19.03 is available. Now, in the DevOps world, whichever software you are using, it will have two varieties. Okay. One will be EE, or the enterprise edition, which is nothing but the paid version. And you will get the other one, which is CE, or the community edition. So community edition will always be free and will come with certain limitations. Like you cannot use it for commercial purpose and all those things. But EE, or enterprise edition, is free of cost. So you don't have to worry about that. EE, in case you are running an organization, you can use it as you want. But anyhow, in our training, as of now, we will not be using enterprise version. Rather, we will be using only and only community edition. Anyhow, I have this Docker version and this set this as my startup. Now, this place where you are seeing right now is known as Docker CLI, or command line interface. This is the place where you write your commands and you run everything what you want to do. Now the question can be asked, where are these commands? How will I know that these commands exist? So a best thing can be for you, you say Docker -- help. The moment you say Docker -- help, a list of some 50 commands will pop up here. And all these commands will tell what they are doing, like Docker image, manage the images. Then you have Docker volume. It will manage the volumes. Now you can say that these details are not that great. I'm not able to understand. So what you can do is you can again come back to Google here and you can say Docker cheat sheet. Now here you'll find 100 of cheat sheets available for you. Whichever you feel is a right one, you can take that and you can start practicing it. Let me say I feel that this one is good one. So it contains all the Docker CLI commands. See here, all the Docker CLI commands are available here, like how to run a new container, how to manage the containers, manage the images, information and statistics. So all these things are present here. So it will totally depend on you, what kind of work you're doing. There's it is not at all required that you go and by heart everything, means start learning up everything. That is not possible. And even if you try it, you will end up forgetting it in a day or two. So I'll not recommend that you go and start mugging up. Rather, you start practicing it. So like there is a command called docker ps. Now what should you do, or what it will do? Show a list of running containers, which all containers are running. It will show me that. So like that, you practice and you will come to know that which thing is running. Now, what we will do is you can take any cheat sheet and you can start. Okay, I'll close this. I'll go to this place. And this is what I will start my work with. Okay. Okay. This online terminal has a small drawback. The drawback is it is active only for 1 hour. Means if you are practicing for more than 1 hour, automatically it will terminate. Okay. So whatever you want, you save it somewhere else, or it will simply terminate after 1 hour. Anyhow, 1 hour is a good amount of time to practice. Now let me do a clear. So I'll clear everything. I will simply come here and run a command called docker images. I can write docker image ls. Okay. I can see so many images are already there. Or I can put it like this. Docker. Let me clean it first. Clear. Or I can say docker images. Now, hey, you wrote the command. I don't know what it is. Okay, fine. See here. So it says, if you use the command docker images, it will list the images for you. And if you say -a, it will show all the images. Okay. If you use filter, it will filter and show you the images. So like this, there are options available for each command. So you can use -help and you will come to know. So if I come here and say docker images, I will be as of now, I'm seeing these many images are running here. Not interested in all these things, but just saw that these images are running. Now, the next question which will be asked is what is images? But before that, let me go here and talk about this guy again. So we started with the first component, which was Docker client. And I told Docker client or Docker CLI is the place from where you will be running all your commands like Docker build, Docker pull, Docker run. So I will teach you all those things. But as of now, just know that there is something called Docker client, Docker CLI, where I run all my Docker commands. Then the second thing, if you see here, is Docker host, also known as Docker daemon. Docker daemon is the engine which is running in the background. So if I come here, I can say service Docker status. So if you see here, there is an engine which is running in the background, and this is the engine, or this is the place where this Docker application container engine or Docker daemon is running. And this is the place where Docker is installed. Okay. So lib systemd docker.services, and I can see it is active and running. If it is not running, 99% it will be running. If it is not running, you can come here and say service Docker start. So it will start running, and then you can come back and check the status. You will see it is active and running. So this guy, which is running in the background, is known as Docker daemon or Docker engine. Once I talk about Docker engine, inside that I see two components, containers and images. Now, what is a container? What is an image? So let's try to understand that. So you all will be aware there is something called matchstick. Okay. Where do you keep this matchstick? In a match box. What do you use it? You ignite it and it becomes fire. Okay, this is your matchstick, right? Similarly, in the Docker world, I have something called Docker image. So Docker image is nothing but it's a file system. This file system contains all the Docker related component, but this is a stagnant version. Stagnant version means we are not running this. Okay, it is stagnant. We are not running this. And if I want, I can store it in my Docker Hub. Docker Hub, also known as registry. So I can save it here. And finally, if I run it, okay, it becomes a container where my applications can run. So this is what I have achieved here, or this is what I can achieve here. Okay. So I told there are three things. One is a matchstick, followed by 1 second. So I started here. I have a matchstick, which is kept inside a matchbox. And if you ignite it, it becomes a fire. So if a layman talks, he may say the matchstick and fire are the same thing. But no, there is a difference. You ignite the matchstick, then it becomes a fire. Similarly, for a layman, a Docker image and a Docker container can be the same thing. But I know that Docker image is nothing but it's a file system. It contains all the softwares, all the components which are required to run, but it is not actually running. It is a stagnant version, or it is a dormant version. It can be kept in the Docker Hub or Docker registry. And whenever you want to run, you use Docker run command, and finally it becomes a container. Now, what are you saying? What is a container? What is a Docker Hub? So let us try to see that. Let's clear all these things. So I came across client, Docker host, and finally, this is Docker registry. Now, Docker registry, I told you, is a place where I will find all the images. Can you show me that? So if you want to see that, you can very well log into, or you can come to Google and simply say hub.docker.com. Now, hub.docker.com is a repository, one of the repositories. There are many such repositories, okay? It is one of the repositories where you can go ahead and store your images. So if you don't have an account, it will look something like this. Again, build and ship any application anywhere. It's Docker Hub. And if you want, you can sign up and create an account. So register and create an account for yourself. Very easy. You can go ahead and simply create an account here. Username, password, and all those things will be needed. So my username is Vikas24775. Click on this, my password, and I am logging in, or I have just logged in. Now, I am running the free version, so it is asking me to upgrade, but I don't want to upgrade because I'm okay with this, whatever I am using. Now, what I'm going to do is I'm going to this section called repositories. And in this section, I can see that there are, explore. I'll go to explore section. And here I can see that there are many images available. Now, when I say many, it is 95,73,926 images. So there are huge number of images available. Now, I don't trust everything. So I will only go for Docker official images, or one which is verified. Okay. Don't go for any random image, because I do not guarantee the authenticity of that software. So if you are very much interested, only go for either Docker official images or verified publishers. Don't randomly start taking anything and start working with that. Okay. So we will try to work with any one software and see how it works. So let me just pick one software. So I'll say Nginx. Now, if you have worked with Nginx, very good. If you have not worked with Nginx, let's go and understand what is this software all about. So here I will come and it says Nginx is an open source reverse proxy. Now, again, what is this reverse proxy? What is this Nginx? So let's try to understand. Now, generally what happens, suppose you have a website or a web server. Let me say this is my web server. So any traffic which is coming from the internet will directly hit my web server. There are high chances there is a virus. There is a high chance it's a malware. There are high chance it's a spam. And if I get all these things, they simply destroy or they simply create trouble for me. So what I do is I don't want the traffic to directly come to my website. I put a proxy server on top of that. So this is my website and this is my proxy server. Now, what happens if we put a proxy? Now, in your college days, even if you're not present, somebody will put your proxy. It means that you are present. So any traffic which is coming will first come to the proxy server. The proxy server will try to check whether it's a genuine one or not, and then it will allow to take it ahead. So even if a software or a malware or a virus tries to attack your website, it will never come to know where the request is actually coming from. So your website will be kind of safe, and you use this proxy server, or we even say it's a reverse proxy server, to safeguard your website. Anyhow, we are not talking about Nginx in further detail as of now, but we will be talking later. Okay, that later I'll tell you when. But I came to know that there is a software called Nginx or Nginx. So there is a software called Nginx. Now the question is how to use this software. So to use this software, the first thing which I should do is Docker pull Nginx. So this is how I can pull the image from hub.docker.com to my local environment. So let me just come here to this guy, maximize it. And here I'm going to run that command. Docker pull Nginx. I want to take the latest content. So I will put it like this, latest. So I'm saying Docker pull the latest image of Nginx for me. Enter. So if you remember, I told image is nothing but a union of file system. So if you see, there are so many layers, and this thing is getting pulled from my hub.docker.com. And finally, it says that I have downloaded a new image of Nginx latest. Now, if I come here and say Docker images, I will be able to see my Nginx, which is the latest version. This is the image ID. And if you see, this has been created some few days back. And the size of this software is 142 MB. So it has been created 13 days back. Now I have this software on my local machine. This is my local machine. Now, what should I do next? So what should I do next? I'm going to run this software. So to run this software, it says, this is how you can run your software. See here, there's a command here. It says Docker run, and then give some name, then -d. -d is detach mode. I'll come into details of this. Then -p is for port forwarding. So it says internally it will run at 80 port number. Externally, I'm going to run it at 8080. And then the name of the image. Okay. So I'll take this and try to execute it and show it to you. So these things are new. It will take some time to digest. But once you start practicing, each and everything will get digested. And we will share these recordings with you, so that you can practice all these things. We'll share the course, we'll share the materials and all, where the commands and all are written. So you will easily be able to understand all these things. So Docker run --name, give name. So say sample Nginx. -d is to run in detach mode. Then -p is for port forwarding 8080, where it should run. internally 80 it will run, and then the name of the image. So what image I have pulled? I have pulled Nginx latest image. Okay. See here, I got a commit ID. Okay. Now if I come here and say Docker PS, Docker PS means process. So I can see one process is running. This is the guy, and it is Nginx latest, which is running here, running from last 10 seconds. From last 9 seconds, it is up and running, and it is running at port 8080. You can see here the port number is 8080, and the name is sample Nginx. Now, if you want to see how it looks on the web, then you can click on this plus button, select the port number, and give your port number. So I gave 8080, display. And here you go. It says, welcome to Nginx. If you see this page, the Nginx web server is successfully installed and working. Further configurations are required in case you want to do more with Nginx. Further configurations are required. So this is basically what I have done. Okay. I will just summarize on a very high level what we have done for today, and then I will open it for questions. Okay. And I can take all the questions which you have. Now, the first thing what I did is I went ahead and I spoke about Docker, why I need Docker, or if I use Docker, what good it is going to do for me. So first I saw there was a problem. The problem was that the environment is different. The code is running in one environment, not running on the other, and there is an unnecessary problem. So I went ahead and took a tool to solve this problem. I came across Docker. When I came to Docker, it says that you can run, build, and ship any software anywhere, but you will have to use containers. To understand container, I should know the concept of virtualization. After that, I came to know the concept of containerization. Now, in my container, I have my binaries, the library, the code, the dependency software, everything together. So I don't have to install anything external. So if you see just now, if I started my work, I did not install any software. I installed only one software, which was Docker, which was already present. So I just need a Docker runtime environment, and that is all what I need. Apart from that, I get everything ready-made. And after that, what I went is I went and started talking about my architecture. In the architecture, I saw that there are three major components: Docker client or Docker CLI, where I run the Docker commands. If I want to know more about Docker commands, I will go to my Docker cheat sheet and I will get everything from there. Even if you don't want to go there, you can say Docker -- help, and you can take the command, what that command will do. Then finally, once the command is there, I can use Docker images and Docker containers to get my work done. All these things will only work if the Docker daemon or the Docker engine is up and running, which is the second component. And the third component for me is my Docker registry, or also known as Docker Hub, where I can get all the containers configured from the company itself. So I took one image, Nginx, and I started running everything there. So I came here and I ran these components. The first, one second. So the first command which I ran was this Docker pull, and I pulled the latest image of Docker. Once I had the Docker image, I just checked using Docker images. And then finally, I ran this command, Docker run -- name, and then the name whichever I want to give, and then Docker -d for detach mode, and port forwarding -p, and then the image which I have. And finally, I ran this command, Docker ps -a, or Docker ps. I was able to see this is the container which is running, and I can see it is running from last 4 minutes and running at 8080. So what I did is I came here and port to view, and I was here 8080. Let me just take it out. 8080, and I was able to see my content. Okay, so this is what we have done for today. And now I will unmute all of you. If anyone has a question, please go ahead. If you want the materials and all, our coordinators will get in touch with you. They will share all the materials, the recording, the material, and all those things. So apart from that, if you have any questions, please go ahead.
Because
Yeah, go ahead, man.
Yeah. So generally for virtualization, what happens if we have a server using VMware, we'll have multiple VMs, right?
Correct.
So in terms of container, so in top of the VM, right, there will be multiple VMs. So if we take one VM, in one VM, we will be having multiple containers. Am I right?
No, I will come to that topic tomorrow. It is there in my agenda. How a virtual machine and a container is different. There are many similarities. Okay. There are many similarities between a VM and a container, but still they are different. So I'll come to that tomorrow and I'll tell you why a VM is not good and why a container is good. In what circumstances you should use a VM rather than using a container. So both have their own drawback.
Will have separate operating system, everything will be there.
I'll come to that. I'll explain it tomorrow. So for tomorrow's agenda.
Yeah. So because
go ahead.
Hello.
Yeah,
because you have run the commands regarding the Docker pull and gave the port numbers. Instead of port numbers, can't we run simply Docker run and Nginx on that?
You can run, but it will not run on an external port number. See, if you want, I can remove these options. So I'll show you. Give me 1 minute. See, you don't want to do port forwarding, okay?
Okay.
See, I can remove everything. I can remove this guy. -D. Okay, minus name. I can remove everything. Okay, I'll just keep -D because I don't want to run in attach mode. So I'll just keep this. I remove everything. Docker. Yes. If you see here, random name was allocated. Clever North cut. It is not running externally. It is only running internally at port 80. And from last 6 seconds, it is running. Okay. So these options and the details of this option, I will come and tell you tomorrow. Okay. But as of now, I just want to tell you that there is something called Docker container and Docker image, which can run on the Docker CLI. That is all what I wanted to show you today. That's it.
Okay. Thank you.
Yeah.
Because what is detach mode and attach mode? D.
Yes, that's what I'm saying. These options I will tell you in detail. Okay. What do you mean by attach mode, detach mode? What is port forwarding? I'll tell you everything. Don't worry.
Hello.
Yeah, please go ahead.
Vikas, can you please explain this? What is daemon?
Daemon is nothing but the Docker engine. So let me say that I am running a software. Okay. Or let me say I'm running my operating system. So when I run my operating system, in the background, the actual software is running. In Docker world, we say it is a Docker daemon or a Docker engine.
Okay.
Yes, your voice is very low, Rama. You can be a bit louder.
Can you hear me? Can you hear me?
Yeah.
Because regarding the Docker daemon, so in Windows, how to start that Docker daemon? Because you showed us Docker daemon start from Linux terminal, right? This is inbuilt
Linux terminal. See, if you're going with Windows, okay, then there is something called virtualization. You have to switch it on. In your system boot option, there will be an option called virtualization. You have to switch it on. Okay.
I'm using Windows 10, Windows 11. So,
okay, do one thing. Just Google how to switch on the virtualization. So on Windows machine, there is an option to switch on your virtualization mode. During BIOS or when you boot your system, then you will get an option. So different machines has a different option. Like if you are using HP, it will have a different option. Dell will have a different option. So depending on your machine, you switch on your virtualization and then you will be able to do all these things.
Okay, thank you.
Okay, I see OnePlus 70 has raised hand. So if you have a question, please go ahead.
Yeah, hi, this is Manoj.
Yeah.
So I have a question not related to this particular today's topic, but regarding a setup. So we are going to install any customized setup like VMware, or I would say workstation on our local laptop. On top of that, we are going to
No, we will do
create
everything
a
on
Linux
cloud
cluster.
environment. We'll do
Sorry?
everything. We will do everything on cloud environment. Nothing goes on my local machine.
Okay, so we are going to use an AKS or something like that?
Yes, we
GK.
will be using our cloud environment, Google environment to work on all these things.
Okay, thank you.
Okay, Muni, you can go ahead.
Hi, because actually have you used the Docker command? There is an 8080 put there. Then after that, there's an you put the colon, then you put 8. Can you explain me?
This thing is what you're talking about, right? This denotes open internet.
Yeah.
So it says on the open internet, if you give port number 8080, it will run. If you want to run at a different port number, you can run it like this. So I want to run it at a different port number. So I'll put it like this. $9,000. And I'll give sample Nginx 1. See here, it is now running at 9,000. 9,000. Okay. Try this. Not this. This 9,000. Okay. It will run. But if the same thing you're trying at 9,001, you did not give 9,001, but you're trying randomly 9,001 or any port number. Okay. 9,001. It will not run. It is not.
So actually, it means every operating system there is a separate
not operating system, tool specific. I'll say like Jenkins run at 8080. Similarly, you have Nexus running at 8081. So every tool has a different port number like that.
So how do we have to this one have to
practice? That will come out with this practice.
Okay, fine. Okay, thanks.
Shamla, so the Docker image is nothing but it's a file system, and the Docker container is the running version of that. So you can say a running Docker image is called as Docker container. So when you execute it, you run it, it becomes a container. When it is not running, it is stagnant, it is sleeping, it is it's a image. If you see from a very high level, both are same only, but that's the only difference. One is running and the other one is a dormant version. Okay.
Hello.
Yeah.
Yeah, Vikas, one more question. How to recognize which port number we need to use
that will come with practice. You cannot just memorize all these things. See, Docker, not only Docker, the entire CI/CD or DevOps world is all about practice. Okay. So you can't memorize everything, not possible. Okay, guys, see you then. Bye-bye.
Because last question.
Yeah.
Because when we talk about Docker and Kubernetes, right? So there is a part of network involvement.
I'll cover that. Docker networking will be there. Kubernetes networking will be there.
Okay.
Yeah. So Vikas, final question. By mistakenly, if we created the image of Nginx with the lower version and we realize that it has to be installed with the latest version, can we delete that?
Yes, you can delete at any point.
Okay, yeah, thank you.
Okay.
Because one small question, microservices also will cover in this.
Microservice in Kubernetes, Istio will be covered.
Still it's covering, right? Okay, thank you.
Istio. microservices.
Hi, Vikas, a small question, not related to today's topic. Is there any scripting knowledge required? This is
No,
the
man,
process.
nothing is required. See, I will teach you in the most simple possible way. Just pay attention in the class, do the assignment regularly. That's it. Nothing else is required.
And also you will cover this course in CI/CD also, or that is not required?
CI/CD I will cover with Kubernetes and Docker.
Okay, thank you.
Okay, see you then, guys.
Hello, sir. I have one question. Can I have my questions?
He left.
He left. Okay, no problem. This class is a free class or a paid class? If anybody knows?
It's a paid class.